Okay, hello everybody. Welcome to day 6. Today we're going to be talking about measures of center and spread. So remember, we went over chapter 1, which was mostly terminology, and then we started chapter 2, which is about descriptive statistics. There we've talked about data visualization, stem plots, frequency, and histograms, and then we talked about percentiles and quartiles and box plots, covering section 2.3 and 2.4 from the textbook. And now we're going to cover sections 2.5 to 2.7, which discuss measures of center and spread. And this will conclude chapter 2 and also unit 1. So the next thing we're going to do is prepare for the celebration of knowledge. It's just around the corner. Okay, in this lesson, the goal is to understand and find measures of center, mean, median, mode, and mid-range. Remember, median we've seen before. Understand and find measures of spread, such as range, IQR, variance, standard deviation. IQR is familiar to us. Understand and find z-scores. And then after that, we're going to discuss resistance. What is resistance? We'll discuss it. And skewness. Okay. Measures of center. There are 4 that we're going to talk about. The first one is the mean. Here, you're given data. You sum up all the data values. Cannot work with categorical data. Sum up all the numerical data values and divide by the total number of data values. And so that's what this glyph right here represents. The sigma there means sum, means you add them all up. The x is a placeholder for the data. So x is a data value. And you sum up all that data and you divide by n, which is the number of data values. And that's the mean. The median, this is the value that separates the top half of the data values from the bottom half of the data values. So this is the ordered data. So it is the middle of the data set. It is the data point that has half of the data above it and roughly the other half below it. This is no different from P50, the 50th percentile. Mode. This is the data value that appears with the highest frequency, or you could say it appears the most. The mid-range is the average between the maximum and the minimum data values. So you've got this whole data footprint from the top to the bottom. What's the middle of that data footprint? That's the mid-range. Let's take an example. Find measures of center of the following data by hand and using Excel. Okay, let's do by hand first. So first thing we want to do is find the mean. So that's going to be X bar is going to equal, and I get 7.525. Now, where do I round? Well, you're always going to round one more than the data. So the data is rounded to the 10th place. So I'm going to round to the 100th place. And so that is going to give me 7.53. So that's my mean. Okay, now the median, X with a tilde above it, I need to find P50. So for the mean, I start by trying to find the location of the percentile, and that's going to be I equals 50 over 100 times n plus 1, which is 8 plus 1. Which is 9. If I multiply that out, I get 4.5. Since 4.5 is not an integer, I'm looking to average the 4th and 5th data values. I organize my data in order. That's what I did in the blue. And I find the 4th and 5th data values of my sorted data. And that gives me 6.3 and 10.0. I average those two and arrive at 8.15. And so that's the median. Next, I need to find the mode. There is no mode. Every point is unique. Okay, so next lastly I need to find the mid-range, and that is going to equal the maximum plus the smallest one, the minimum, over 2. I average the maximum and the minimum, and I get 7.3. So those are all of my measures of center, and the units of each of these is millions of dollars. So there we have it. Now, where did this data come from? Well, this is actually the earnings of the Coldplay albums. Okay, measures of spread. There are 4 measures of spread that we're going to discuss. The first is the range. This is simply the distance between the maximum and the minimum values of the data. The next one is the interquartile range, which is the distance between the third and first quartile. We've seen that one before. The next one is the variance. Now this is the mean of the squared deviations or differences from the mean. So you've got this mean, and you take every data point and you subtract it from the mean. So you find how far away it is from the mean. You square that distance, and then you sum each of those up, one term for every data point in your set. And then you divide by n minus 1. And that gives you your variance. The variance has a strange symbol to represent it. It is s squared. So that's the variance, s squared. The standard deviation is the square root of the mean of the squared deviations, differences from the mean. So notice that this right here, the standard deviation, is just the square root of the variance. And so that sort of justifies why the variance has such a strange symbol representing it. Really, it's the standard deviation that we are most interested in. But the variance is important too. Now notice that the units of the variance is going to be whatever the original units were squared. So that's the units for the variance. And the units for the standard deviation is just going to be the original units. Because when you take the square root, you take care of all of the squares that happened here. Okay, so the standard deviation is a fairly unusually looking statistic, but it turns out to be very helpful in quantifying the spread of a data set. Let's go back to our example of the Coldplay album sales, and let's find the measures of spread for the following data, and let's do this by hand. So we already know that the mean is equal to 7.53. Now, should we round or not? Generally, the thing to do is to not round. So let's keep it like that. Only round at the very end. Okay, so s squared then, the variance, let's find the variance first and then take the square root of that and get the standard deviation. We're going to go with the hardest ones first. Is going to be, and then we're going to divide all of that by 7. So notice each data set, each data value has its own term in this sum. And then we're going to divide by the total number of terms minus 1. So n minus 1, so that's 7. And if I do all that, I put all that into my calculator, I should get 21.7107. Right. Okay, but where do we round? 1 decimal place more than the data. So I'm going to get rid of all of that right there and round it at 21.71. And what is it? Millions of dollars squared. So whatever that is, that's the unit. Now S is just going to be the square root of that. And again, you don't want to round till the very end. And I end up getting 4.66 millions of US dollars. So that's my standard deviation. Okay, now let's find the range. The range is going to be the largest minus the smallest, so that would be 13.9 minus 0.7, which equals 13.2 millions of dollars. And now the IQR, we're going to need to find the first and third quartile. Okay, so let's do that. So I wanted the second and third value, so that'll be 3.6 for Q3, which is the same thing as P75. I is going to equal that gives me 11.05 if I average 10.2 and 11.9. And so now what I need to do is find the difference between them. So that's going to be 11.05 minus 3.6, and that is going to give me 7.45. And I round it to the 100th place, and so there's my IQR. And again, the units on this is going to be millions of US dollars. So there are my measures of spread. Okay, so to see this in Excel, what we're going to do is take the data and put it in. Okay, looks like I've got all 8 of them. And now, so when we're using Excel, so first we put in our data, and now I want to use some of the Excel functions. I don't want to have to add all these all up by myself. So in order to access an Excel function, I'm going to be in a cell, I'm going to push equals, and that lets Excel know I'm going to use a function. I'm going to type in, for the mean, I'm going to do average, and there's this pop-down menu with a bunch of choices. So there's average. I don't even need to finish typing. I'll go ahead and click on average. And now it wants the numbers that I want to average. And what I can do there is I can select a range and put that in. So while the number 1 argument is selected, I'm going to go ahead and push A2, which is the first cell my data is in. I'm going to drag that box with the dancing ants around it all the way down to A9, and I'm going to push enter, and there it is. Gave me the average of that range. Okay, the next one we want is median, so I'll go ahead and do equals median. Well, let's see. There it is, median. Okay, so same thing, select that, enter. There's my median. Let me go ahead and organize these things here. So I'll go mean, which I'll just type mean right in there, use a colon. So that's my mean. Median, that's that one. Mode. Okay, now let's see what it says. Now we already determined that this thing is not going to have a mode because every number is unique. So I'm going to go ahead and do mode, drag it down, enter, and A. Okay, there you go. So no mode. Okay, and then the next one is mid-range. Now, mid-range is not used very often, so I don't think there's an Excel function for it, but let's check anyway. Equals mid. What's mid? Mid, text start, returns the characters from the middle of a text string given a starting position and length. Well, that is certainly not what we want. Okay, so doesn't seem to be a mid-range, but not to worry. What we'll do is we will subtract the maximum, the max of this data set. Not subtract, sorry, add. And take the max, close parenthesis, plus, now Excel always gives me some trouble. There, okay, plus the maximum plus the minimum of this data range. Notice it didn't matter that I used lowercase letters. I'm going to put all this in parentheses. You see that? And divide by 2. And so that's my mid-range. The biggest plus the smallest divided by 2. And I'll press enter. And there it is. Okay, so these are the measures of center. Now let's find the measures of spread. So the first one is the range. Okay, click on this free cell, equals. I'll take the max again, subtract the min, And there's my range. Oops, misspelled that. Okay, the next one is the IQR. IQR equals, let's try IQR. Okay, IQR didn't work. Let's try inter. No. Okay, let's try quartile. Okay, so we'll go with quartile. Put in the range here. And then we'll put in 3 for the third quartile minus quartile. There's the same range minus the first quartile. That's what we want. Okay, equals. And that looks a little different from what we found. Excel has a particular way of finding the quartiles, and that way is different from the way that we find the quartiles. Now, for the homework, you're going to want to do it the way that we do it, so you don't need to use Excel for that. But for the celebration of knowledge, either use the way that we've learned in the previous lesson or using Excel. It's up to you. Okay, the next one is the variance. That is going to equal, let's see, var, let's check. This function is available, estimates variance based on sample. Okay, very good. That's what we want. So parenthesis, grab that array, close that, enter, that looks familiar. And then stdev, I forgot my equal sign, equals stdev dot p dot s, we want, well, let's check. Estimate standard deviation based on a sample. What's the P one? The dot P is calculate standard deviation based on entire population. Okay, so we want the one for the sample. Okay, so I'll click on that one. I'll put in my data range. There, close that. Oh, it's not gonna like this. Enter, whoops. Okay. stdev equals stdev.s. There's the range. Enter. Okay. And there it is. There's an interesting thing with variance and standard deviation. If the data that you have is regarded as a population, the formula is a little bit different. So the formula that we're going to be using most is the one for samples. And that one is this one right here. So if you're dealing with a sample, which we almost always will be, we're just going to use this with the n-1. However, if, and we may do this once or maybe twice throughout the course of the semester, if our data is regarded as a population, such as we have all of the Major League Baseball players. I mean, it's not an infinite list, it's not super big. Or maybe all of the gold medalists, right? That's a population. Then we would use this formula for the population. It's slightly different. The only thing that's different is the n. Is the n there. Okay, now notice, though, the change in the variable. So for a population, this is no longer a statistic. This is a parameter. And these are statistics. So this is the first time we see this very interesting convention. If the number represents a sample, a statistic from a sample, we use normal Roman lettering. If, on the other hand, the value represents a population, we use Greek lettering. So the sigma is the Greek S. All right, now let's talk about significance, which is, as the name suggests, a very significant topic. So we have the range rule of thumb. And the range rule of thumb states basically this: most of the data is in 2 standard deviations of the mean. which is roughly the middle. And so what that tells you is that the range is about 4 standard deviations. So you have your data, and here's the mean, and then most of the data is within 2 standard deviations away from the mean. So that would be like this interval right here. And so notice that whole range there, that whole where most of the data is contained in 4s, a distance of 4s. And so what that tells you is that range is sometimes or usually close to 4 times the standard deviation. So data outside 2s of the mean, x bar, is unusual. That's the range rule of thumb. And we are going to replace the word unusual with significant. Okay, now let's talk about z-scores. Z-scores are a way of standardizing data. What do I mean by standardizing? Well, standardization carries with it this idea of it being situation independent. So mice, 6 ounces above the mean is extreme. This number is associated with the context of it being mice. So it's not true that if an elephant is greater than 6 ounces above the mean, that it is extreme. So this 6 ounces is not standard. When we talk about standard, we mean something that can be applied to all sorts of different data sets. And so what we do is we're able to take out the context in a way. So for a data set, you have the mean and you have the standard deviation. And so what you do is you subtract from each data point the mean and divide it by the standard deviation. And so what this tells you is how many standard deviations that data value is from the mean. If it's positive, greater than 0, that means it's above the mean. If it's smaller, if the z-score is negative, less than 0, then that means it's below the mean. And if the z-score equals 0, well, that means that your data value associated with that z-score is the mean. Okay, let's go back to our Coldplay album sales example. The z-score associated with this first data value is going to be 10.2 minus 7.53, which is what we're using for the mean, and we'll divide by s, which was 4.66. I'm just going to use these rounded variables for now. And so that gives me 5.72961. And where do we round it? Well, we'll just round it to 3 decimal places. The convention of rounding one more than the data doesn't make sense here because this has been standardized. So if we talk about the unit of the top is the original unit and the unit of the bottom is the original unit. And so if I divide that, this whole thing here is unitless. It has no unit. So you just always round it to about 3 decimal places. Okay, great. So that's that first one. Now, if I do the other ones, I end up getting 1.667. And so here we have all of the z-scores for every piece of data in that data set. So the 11.9191 here is almost 1 standard deviation above the mean. This 13.91 is 1.3 standard deviations of the mean. So that's a bit, it's not extreme though, right? It's not beyond 2 standard deviations. And then this one here, even the lowest one, that's not even 2 standard deviations below the mean. None of these would be significant according to the range rule of thumb. Okay, with that, let's talk about resistance. Now, resistance is the degree to which the statistic is affected by outliers. All right, so is it highly affected or not? So let's go through our known statistics now. So we've got the mean. Okay, now is the mean going to be affected by outliers? And the answer to that is yes. It'll be highly affected by outliers. And that's because the value of every data point is used. And so if one data value is super high, that's going to mess up the mean. That's going to affect the mean. The next one is median. Now, is the median resistant? Is it resistant to outliers? And the answer here is yes. It is resistant to outliers. This is because the values at the extremes don't really matter. Those don't go into account when we're talking about the median. Whether the highest value is 100 or 1 billion, it matters not. All that matters is that it's above more than half of the other values. So median is resistant. The mode is also resistant because these extreme values are not likely to appear with the most frequency. And so in general, those will not compromise the mode. Those will not change the mode at all. Next one is the mid-range, and this is definitely not resistant. It is highly affected by extremes. Okay, let's go over the measures of spread now. So the first one was the range. What do you think? Not resistant. Same as with mid-range, right? I could put my ditto marks here, or highly affected by extremities. Next is the IQR. Now this one is resistant because, again, we expect these extreme values to have a low frequency, so they're not going to move the Q1 or Q3 very much. Okay, so the values of the outliers will not move Q1 and Q3 very much, and that is what goes into finding the IQR. Next is variance and standard deviation, and these are not resistant because, again, the value of every data point is used. Let's go ahead and color. If it's resistant, we will color it red. Median is resistant, mode is resistant, IQR is resistant. Everything else is not resistant. If it's not resistant, we'll color it in green. Not resistant. Okay, let's take a look at the histogram now. So here is a histogram of data. Now what we have in this is the 2023-2024 Premier League annual wages. So this is in millions of dollars. 224 people have a salary, an annual wage, between 0 and 2 million. And then 168 have a salary between 2 and 4 million, and so on. And it looks like one player has an annual wage between 26 and 28 million. Okay, so there's the data. Now let's take a look at this. So the mode here, the mode of the data. Now you wouldn't be able to determine any of these, mode, median, and mean. You wouldn't be able to determine any of these accurately just by using this histogram. I made this histogram, and from the data that I had, the mode turned out to be 0.66. So the most one salary that anybody got was $660,000 a year. The median salary is 2.98 million, and the average salary is 4.11, and the standard deviation here is 4.5. Now, the thing to notice here is that this has what we would call a long tail. Okay, so the tail on the right is much longer than the tail on the left. There's hardly any tail on, there is no tail on the left. And so this is called right skewed. And that's generally how salaries tend to go. Let's take a look at the box plot. So here's the median. That lines up with the median. Look at all these outliers, right? So we've got the IQR, which is that distance right there. And if you multiply that by 1.5 and add it to Q3, which is right here, you have the outliers. And so every one of these is the outliers, and there are a number of them. There's at least 11. All of these here are outliers. 6, 6, 12. So there's about 33 outliers. So that's highly skewed. And so the mean here, the mean is quite a bit above the median. So the mean is not a very good representative of everybody. In this case, maybe the median is better. That being said, it's very interesting to look at stuff like this. So usually median is a better way of looking at salaries. According to this, more than half of the actual Google employees make over $316,000 a year. And then you have NVIDIA, which is a big chip maker that's been growing a lot, and so on. So, and then Amazon, down there at the bottom. And this right here is the national the national median. So Tesla is below the national median. Okay, anyway, interesting. Okay, here's a little something that might help you to remember which way the mean goes. So the mean skews towards the tail of the histogram. All right, let's go ahead and recap. So what we talked about today was measures of center, and there were 4 of them. Then we talked about measures of spread, which gives you an idea of how spread out the data is, and there were 4 of these. After that, we talked about range rule of thumb and z-scores, resistance, and then skewedness. So skewedness involves having when your plot has a long tail. Okay, so that's that. Thank you very much. Everybody have a wonderful day, and we'll see you next time.